This is D2.7 on page 11 on calculus. It says the graph of the cubic function is given by ax cubed plus bx squared plus 9x. The graph has a turning point 1, 4. Calculate the values of a and b. Now we must always remember the turning point can be used for two purposes. One is the derivative and the other is the direct substitution of the coordinates. So if we take the derivative in the first instance, you will get f prime x is equal to now 3ax squared plus 2bx plus 9. Now, and this derivative is equal to 0, and then we can substitute x equals 1, and we will find that you've got 3a plus 2b is equal to minus 9. And then if we substitute the coordinates directly there, f of 1 in the, then you will get a plus b plus 9 is equal to 4, giving us a plus b is equal to minus 5. And when we solve these two equations simultaneously, you will get a is equal to 1 and b is equal to negative 6. This is problem E1, and it is on maxima and minima, maximum and minimum, and using that to solve some problems, especially a special rectangular milk carton on a square base holds 1,0 to 4 liters of milk. If it has a specifically designed fold in top, the area of which is 3 times the area of the base. Calculate the dimensions of the carton so that minimum area of cardboard is used, and find this minimum area. Now you notice we've given the volume, so what we're going to just quickly try to get a sketch going for you, and that would give us and then you've got this the area of this 3 times the area of the base. Okay, now if you look at that, now we are given when you are given the capacity, then it becomes volume. So volume is equal to, because it's got a square base, so we let each side be x, then you've got x squared times h is equal to, converting that to cubic centimeters, which is 1024, and then we can say that h is equal to 1024 is equal to 1024 times x to the minus 2. Now this is always a good strategy, because eventually what we really want to do is to express this in one unknown. So we want the area. Now the area of the what we have is, if you look at this, it's a perimeter of base times the height, which actually is 4x times h. And then we've got 4, if you look at the base, because the fold up is 3 times the base, so it will be plus 4x squared. Now what we have is to substitute for h, and that would give us 4x times 1024 times x to the minus 2 plus 4x squared. So what you get here now is 4096 times x to the minus 1 plus 4x squared. Now we obviously want to, the question read, calculate the dimensions of the minimum area. So we want to minimize that. So a prime x is equal to minus 4096 x to the minus 2 plus 8x equal to 0. So what we now need to do is to now solve for x. So we will end up with 8x cubed is equal to 4096, and that would give us x is equal to 8. Now when x is equal to 8, so your length is 8 centimeters, your width or breadth is 8 centimeters, and the height is 16 centimeters. So those are the dimensions. And then they want, in the next part of the question, was to find the in 1.2 to find the minimum area, and the minimum area is equal to obviously the minimum area would be substitution in the original, and that would give you 768 square centimeters. You need to substitute in the original. So the original is there, and if you do the substitution of x is equal to 8 in the original, you will get the minimum area. This is E2 on page 11, calculus, and a small factory can produce 200 pairs of shoes per week and sell them at 80 Rand per pair. For each increase of 4 Rand per pair, one less pair is sold. Now if there are x increases, then expressed in terms of x, the number of pairs of shoes sold. And now 2.1.1, we are talking about the number of pairs of shoes sold. Obviously it's 200, and if there are x increases, minus x. Then we're looking at the next part of our problem, which is 2.1.2, price per pair of shoes. 2.1.2. So what will happen is the price per shoe. Now this is an increase, so, and each increase will involve 4 Rand per pair, right? So it will be, the number of increases is x, so it will be 80 plus 4x. And the third one is the total receipts. So the total receipts will obviously be the number of pairs times the price, which is 200 minus x times 80 plus 4x. And then now calculate the number of pairs of shoes to be sold to maximize receipts. Now we want to find the derivative of this and equate it to 0, which is 2.2. And you remember I spoke to you about finding the derivative of the product of two binomials, which is the derivative of the first times the second plus the derivative of the second, which is 4, times the first, which is 200 minus x, and equal to 0. So we need to solve for x, and x is equal to 90. Now what they required was calculate the number of pairs of shoes to be sold, and so the number of pairs of shoes to be sold will be 200 minus x, so that would be 200 minus 90 would be 110. And then the next question was, at what price must each pair be sold to maximize receipts? Now the price, remember, is 80 plus 4x. Now that's going to be a substantial amount, because it will be 84 times 90 is 360 plus 80 is 440. So that would be, in other words, the price would have to be 440 rands. And then we now are being 4.2 should actually be calculate the maximum receipt should actually be 2.4. So we'll make the necessary adjustment, 2.4, and that would be the product. So the maximum receipt would be the product of the number of pairs of shoes and the price per shoe, which is 440 times 110, giving us 48,400 rands. This problem is F1 on page 12, and it is an object is shot vertically upwards. Its height h in meters after t seconds is given by 25t minus 5t squared. 1.1 says find the average velocity. Now we know that velocity is related to speed, and the change in distance divided by the change in time will give us speed, and average velocity is like average gradient, and which means that the average velocity is, now over the 2 seconds it will be h of 2 minus h of 0, all divided by 2 minus 0, and that would give us, if we substitute, you will get h of 2 is 50, and h 5t squared is 20 divided by 2, and that would give us 15 meters per second. Then we've got 1.2 is the maximum height reached. Now the maximum height reached would obviously be the derivative, so h prime t, and your derivative is 25 minus 10t, and your maximum is when the derivative is equal to 0, and here we will get t equals 2,5, and then we need the maximum height, so we say we have to substitute h of 2,5, and we end up with 31,25 meters, which is the maximum height. And then they wanted to know after how many seconds would we reach the maximum height, that is t is equal to 2,5, because it has already been worked out. Now looking at the other questions, we're going to go on to 1.4 is initial velocity, and then 1.5 is velocity after 2 seconds. So 1.4 initial velocity is, we can say v of 0, which was the h prime 0, and the initial velocity is replacing t by 0, you get 25 meters per second. And then the velocity after 2 seconds, v of 2, velocity after 2 seconds. So we have to now substitute, replace t by 2, and when we replace t by 2, so you'll get 25 minus 10 times 2, and that gives us 5 meters per second. And then we got 1.6. The 1.6 says, when will it reach the ground again? So what we actually need to do is to equate 1.6, when will it reach ground again? You remember we now have to solve and then the equation, and then the equation, when you solve, when you make it equal to 0, then you will get t equals 5. It's just t equals 0 or t equals 5, so it will hit the ground again. So 1.7 want to know after what time will it be 20 meters above the ground. So in other words, 25t minus 5t squared is equal to 20, and then when you solve for t, you'll get t equals 1 or t equals 4. This problem is G1, and you will notice it's the multiple choice that we've added on. The coordinates of the point of inflection is given, and they want you to find the value of B plus C. Now it is fairly obvious that some of these problems you don't really see. Now we know the point of inflection is the second derivative. So if you look at the first derivative here, y prime is equal to 3x squared plus 2bx, and your second derivative is 6x plus 2b, and we are given that this is equal to, we know that if you had to even find your turning points as well, I gave you that as the other option as well, and we know that the other option works. Let's look at both as well. So this is 3x squared plus 2b is equal to 0. 2bx is equal to 0. So you've got x is x into 3x plus 2b is equal to 0. X is equal to 0, or x is equal to minus 2 over 3b. Now, if you remember very carefully what I did say, that if we find the sum of the x values divided by 2, we will get the 7 over 3 that we're talking about. So if we add those two, it'll be 0 all divided by 2 will give us the 7 over 3, and that would mean if I had to multiply it out, so we'll have minus 2 over 3b is equal to, cross multiplying, is 14 over 3. So you notice straight away we have minus 2b is equal to 14 and b is equal to minus 7. So we've got b is equal to minus 7, and what they also tell us that if we substitute into the original, if we go back, substitute into the original, now you notice the original is x cubed plus bx squared plus c, and we got 7 over 3 and 286 over 27. So substituting that in the original, so we got x, we will now say 7 over 3 cubed, and we add the plus minus, we've got also minus now 7, and the b we use 7x squared, so which is 7 over 3 all squared, and plus c must be equal to the value that was given as 286 over 27. And then now it's quite easy to solve for c, and c is equal to 36. Now the question read, find b plus c. b plus c is 36 minus 7, which is 29. Now I thought this was an easy option for you to do, and so what you noticed that obviously if we go and solve for x here as well, we'd have got equal to 0, and then you've got x is equal to 1/3 of b, which is minus 1/3 of b, which you would obviously equate to 7 over 3. So that is the other option that you had.